Right, welcome. Hi, good evening. Shall we start? Hello, sir. Good evening. Shall we start?
Yes, sir. Good evening. Start. We can start.
Okay, thank you. So, in the last class, we start with the DC fundamental. Number one, Ohm's law. At constant temperature or room temperature, the current is directly proportional to voltage. Number two, resistance, resistivity. R is equal to rho L by A, where R is equal to resistivity, L length, A area. And on the other hand, we have conductance, conductivity. Conductance is denoted by the letter G. It's a reciprocal of the resistance. So that is G is equal to 1 by R. The unit is mho or Siemens. And conductivity is a reciprocal of the resistivity. Then we discuss about the formula for various resistance for various temperature. RT is equal to R naught into 1 plus alpha naught into T, where RT resistant at T degree, R naught resistant at 0 degree, alpha naught temperature coefficient, T temperature. So from this what we understand, if we have a positive temperature coefficient, it is a conductor. Negative temperature coefficient is an insulator or semiconductor. Then we come to the Kirchhoff's law, Kirchhoff's voltage law and current law. Kirchhoff's current law, at any node, sum of the current entered is equal to sum of the current leaving. Come to the Kirchhoff's voltage law, in a closed circuit, sum of the voltage rise is equal to sum of the voltage drop. Then we come to a series parallel circuit, series connection, total resistance R is equal to R1 plus R2 plus R2 up to Rn. If all the resistance are same, N into R. In the series circuit, current is same, voltage is different. If you come to the parallel circuit, total resistance 1 by R is equal to 1 by R1 plus 1 by R2 up to 1 by Rn. If all the resistance are same, R by N. For two resistance, R1 into R2 divided by R1 plus R2. Parallel circuit voltage same, current different. Then we come to the general formula, power P is equal to voltage into current. Energy E is equal to power into time taken. Ideal condition, heat energy is equal to electrical energy. Heat energy in terms of joules, electrical energy in terms of watts. That is watt hour. Electrical energy in terms of watt hour. Then we come to the two important rules. One, voltage division rule, current division rule. Voltage division rule, total voltage divided by sum of the resistance into same resistance. That is, we need to calculate the V2, that is V total voltage divided by R1 plus R2 into R2. If we come to the current division rule, total current divided by sum of the resistance into opposite branch. So to calculate the I2, total current divided by R1 plus R2 into instead of R1 we put R2. Sorry, instead of R2 we put a R1. So voltage division rule, current division rule. Then in a parallel circuit, the total resistance value always less than the least resistance. Series circuit, total resistance value always greater than the greatest resistance. So these are the informations what we discussed in the previous class. Then we have theorem is there. The theorem is applicable for DC fundamental, AC fundamental. So that's why just we start with the DC fundamental. Then we come to the theorems. So today we discuss about the AC fundamental, and if time permits, we discuss about the theorems also. Okay, what is the difference between the DC and AC? AC with respect to the time is constant. With respect to the time, the AC is a variable quantity. So simple understanding, we take a CRO. In our college, we are using the CRO. In the CRO, if we are giving a DC supply, we have a waveform like this. Straight line. In the CRO, that from this what we understand, with respect to the time, the voltage is always constant. If we are giving the AC supply, we are getting this waveform. So from this what we understand, if the time increases, the waveform is, the voltage also is changing in nature. Because at t is equal to 0, we say for example 10 voltage. So at t is equal to 0, we have voltage 0. After few seconds, for example say 5 seconds, what is the voltage? The same 10 voltage. But here after 5 seconds, maybe the voltage like this. So from this what we understand, if the time is increasing, if the time changes, the voltage always constant in the DC supply. In the AC supply is changing in nature. So simple understanding, if we take the battery always give the 1.5 voltage. But here we say we have 240 voltage. But if we calculate in the CRO, it's changing in nature. With the time to time, it's changing in nature. So that is the difference between the AC and DC. So we come to the AC supply. With respect to the time, the voltage is changing in nature. In what way it is changed? It is changed in the sine waveform. It is changed in the triangular waveform. It is changed in the square waveform. It is changed in the complex waveform. All we call as a alternating voltage. But more specifically, we discuss in the sine waveform because in our daily life, we are using the sinusoidal voltage. Especially in the electronics, we studied that to produce a square waveform, to produce the triangular waveform. So all we call as alternating quality because with respect to time, it is changing nature. Or in our home, we hear the music in the home theater. In the home theater, there is a display is there. Like this. It is also we say it's a AC because with respect to the time, the quantity is changing in nature. Okay, but now we come to the exam point of view. We discuss about sinusoidal voltage because all the electrical equipment we are giving the AC volt, sinusoidal voltage. Instead of AC, we specifically use the word sinusoidal voltage, but hereafter we always use the word AC voltage. AC voltage means it is a sinusoidal voltage. Similar to our contract document. In the contract document, first party, second party. First party client, second party subcontractor. Here we use the word AC voltage, but it not refer all the things. It refers only sinusoidal voltage. So where we get the DC voltage? We are getting DC voltage in the battery, or simply we use the word cell, or we get the DC voltage in the solar panel. Where we get the AC voltage? We get the AC voltage in the alternator. What is the alternator? Let me discuss in detail in the machines topic. Right now, alternator is an electrical apparatus or electrical machine which is used to convert mechanical energy into electrical energy. So simply we say we have a mechanical energy which is converted to electrical energy. So alternator, that means here it is alternator. In the alternator, so is coupled with the prime mover. So simple understanding, in our school days, we are using the bicycle. In the bicycle, there is a cycle, back tire is there. The tire is just like a prime mover because we pedal, so that's why the tire is rotating. So thereby we are getting the mechanical energy. That mechanical energy, the rear wheel, that is back wheel, we are using the dynamo. In the dynamo, there is a small button is there. We press the button, so there is a knob is there. That knob touch the cycle tire. So thereby the tire is rotating. Thereby the dynamo. That is the dynamo, the rotate. Simply we say dynamo rotate. More specifically, the armature is rotating. So let me discuss in the later stage. So in the cycle, we are using the two things. One is a cycle tire and also dynamo. So the cycle tire just like a prime mover, the dynamo just like a alternator. So from this what we understand, we are riding a bicycle, we are getting the electrical energy, which means the mechanical energy is converted to the electrical energy. So mechanical energy convert to the electrical energy. So where we get the mechanical energy? From the cycle tire, that is rotation of the tire, or we say the prime mover. The prime, that is we are giving the mechanical energy, which means it is a rotation. The cycle tire is rotate means is rotate 360 degree. So that's why here we are getting the 360 degree. Just like you imagine, just like it's a cycle tire. So the tire is rotating, ideal condition, the tire is a 0 angle, start rotating, so like this. So 0, 15 degree, 30 degree, like this is rotating. So similarly, we have a 0 degree to 360 degree, like assume that. So now we have a mechanical. How to measure the angle? Assume that it's a cycle and it's a wheel, it's a rest at 0 degree. Now it start rotating. So 15 degree, 100 degree. By this way, the angle is increasing. So rotation means what the meaning? There is some angle is there. So mechanical energy, more specifically here we use the word angle. So here we have an angle. How to measure the angle? Either in degree or in radian. So degree means we may say what the angle for this circle? 360 degree. Okay. Instead of degree, we may say in terms of radian. What the angle of the circle in terms of radian? 2 pi. So from this what we understand, 360 degree which is equal to 2 pi. So either we may say in terms of an degree or in terms of radian. So that's why here we have a angle. Here we have a rotation. This rotation we get from the cycle tire. We get from the prime mover, which is coupled with the dynamo. In the dynamo, light is glow. So from this what we understand, the dynamo produces electrical energy. The electrical energy in the form of waveform. For example, once complete rotation of the tire, which gives one complete cycle. Here one revolution we say. One revolution means 360 degree. Here we are using in terms of mechanical quantity. We come to the electrical quantity, instead of one revolution, we say one cycle. Here we call it a one revolution, here we call it a one cycle. One cycle, what the angle? One cycle means one complete thing. So here also we say one cycle means it's nothing but a 360 degree. So here also we say 360 degree. Here 360 mechanical degree, here 360 electrical degree. So ideal condition, one revolution. So for example, say revolution per seconds. So here what we say that here is not a revolution, here we have a cycle. So cycles per seconds. So in the mechanical we call it a RPS, in the electrical we call it a cycle per seconds, or we may say hertz. So that is the relations between the mechanical quantity and electrical quantity. So why we get one complete cycle will refers one revolution. So here we are using the word theta, which is equal to angle in terms of theta. Here also we may write in the x-axis theta. So that's why we have a put a angle. But theta is a mechanical quantity. In the electrical quantity, we didn't use the theta. Instead of theta, we put a time taken. That means we need to correlate the theta and time taken. So mechanical we say theta, in the electrical we say time. So what is the relationship between theta and the time? So simply we use the word omega is equal to 2 pi f. So what is F? F is a frequency. F is equal to frequency. What is the frequency? F is equal to 1 by t. So F, it is a F is nothing but a time, because its default is related to the time taken. What is the omega? Omega, it is angle. So angle we may refer either theta or omega. Both are angle. So the theta we call as a net. So both theta, the theta, whether we put a degree or radian, in both we say that theta. So we come to that frequency, because we forget about the mechanical quantity, we come to the electrical quantity. In the electrical quantity, that is frequency, the frequency either denoted by F or omega. So F stands for frequency, omega stands for frequency. What is the relationship between the F and omega? F we call as a natural frequency, omega we call as a angular frequency. Natural frequency denoted by the cycles per seconds. Angular frequency denoted by radian per seconds. So right now here F, here omega, here hertz, or we may say cycles per seconds, here radian per seconds. So natural frequency is hertz or cycle per seconds, angular frequency radian per seconds, omega. Mostly this term we are using in the control systems. This term usually used in the circuit theory. So usually in the circuit theory we are using the word F. In the control system we are using the word omega. So what is the cycle? A cycle is a one complete. We have a one complete revolution, that means one positive cycle, one negative cycle put together we call it a one cycle. One cycle having 360 or 2 pi. So right now we discuss about the electrical quantity, forget about the mechanical term. So this is we call as a one complete cycle. The complete cycle having 360 or we may say 2 pi. Okay. So in our exam, rarely you may have this question. Convert degree into radian or radian into degree. For example, from this what we understand, 360 is equal to 2 pi radian. So in your exam, they ask the question, convert 540 into radian. So this question also asked in the exam. So how to convert this? We know the formula. 360 is equal to 2 pi radian. So simple mathematics, 10 mango is equal to 100 real, 15 mango is equal to how many real? So simply we put a 540 which is equal to 2 pi divided by 360 into 540. That's all. So simple mathematics, we find the angle. So again, this question asked in the exam, but rarely. Out of 10 engineers, may one engineer occasionally solve this question. So similarly, we may convert radian to degree. Okay, this is, so from this, time taken T is equal to 1 by F, or we may say F is equal to 1 by T. So natural frequency, the unit is cycle per seconds or hertz. Angular frequency, we say radian per seconds. Cycle per seconds, radian per seconds. So here we are using that 50 hertz. So F is equal to 50 hertz. What is the T? T is equal to 1 by 50. So we get the answer. The same question in the communication circuit, they say that F is equal to 200 kilohertz. what is the time taken. Here also the same formula. The formula is the same, but this question related to the electrical, this question related to the communication. So here we didn't, there is no need to worry about that. We need to remember the formula, we need to answer, that's all. So now we come to that. So if you come to in the DC supply, simply we use the word voltage. Suppose if you come to the AC supply, sometimes we are using the word RMS voltage. Simply as a construction engineer, we are using the word voltage V. In our always, in our BOQ or in our all the document, we use the letter V. Because I am a site engineer, that's why I use the word, what is the voltage level? 11 kV. What is the voltage level? 440 voltage. This is the word, as a site engineer, I use that word. But he is a consultant engineer. So because he is the authorized person to approve the material. So now I submit on material submittal for the isolator or submit the MCP. In the MCP, as a site engineer, just I receive the document from the vendor and submit it to the consultant. I didn't, as a site engineer, I didn't go through the document. What is the words mentioned in that? As a site engineer, I purchase the isolator and remove the box and keep the isolator. But as a consultant engineer, he read what are the informations, write in the boxes. In the isolator or in the MCP, they mention the word VP. Or they mention the word VM. VP stands for peak voltage. VM stands for maximum voltage because the isolator withstand the maximum voltage, peak voltage. These are some terminologies. So similarly, in the AC supply, we are using 4 different terminologies. One, everyone knows the word V. Simply we use the word capital letter P, which is, or we may say VRMS. V means refers the RMS voltage. So VRMS, V are both are same. Next term we say VM or we may say VP. We call say peak voltage or maximum voltage. Preferably, mostly electrical engineering, we use the word VM. In the electronics, we use the word VP. But both are same. VM, VP, peak voltage, maximum voltage. And sometimes we use the word VAV. AV stands for average voltage. Usually we use this term in the transformer EMF equation, alternating EMF equation. We are using this word, average voltage. And the last one, we use the word small letter V. Small letter V stands for instantaneous voltage. Small letter always refers the instantaneous. So we have 4 different notations are there: instantaneous voltage, maximum voltage, RMS voltage, or average voltage. So we have 4 different terms are there. What are the relations between these 4 terms? So in our exam, we have a question using these things. And in our problems also, we are using these terms. Sometimes they are given data in terms of RMS, sometimes in terms of maximum voltage or RMS voltage, that is instantaneous voltage, like that. So we need to relate to all these quantities. First we start the instantaneous voltage. So usually what we do, in the x-axis we have put a theta, in the y-axis we have a magnitude. Now instead of electrical engineering, now we go to that mathematics. In the mathematics, in the x-axis theta, in the y-axis we have amplitude. So in the sine theta, because the waveform is in terms of sine, just similar to the sine waveform. Sine 0, what is the value? Sine 0, 0. So Here x-axis theta, theta is equal to sine 0, 0 value. Sine 90, maximum 1. So that's why sine 90 degree, that is 90 or pi by 2. So we have a maximum value. So this value we call as a maximum. And here we have a negative maximum. 270, we have a negative maximum. Okay. So now, instead of that, we keep the theta, instead of our understanding, but instead of the maximum, we use the word so now you come to the electrical engineering, instead of amplitude, we use the word voltage. And more specifically, this point is a maximum voltage. But this curve, entire curve, refers the voltage. That's why we put voltage. In the y-axis, we have voltage, x-axis, we have a theta. So, at 0 degree, voltage 0. At 90 degree, the voltage is Vm. What is the voltage at this point? What is the voltage at this point? So, in the entire curve, we may find the value for this any points. So, any point that we call as a instantaneous. What is the voltage at this point? What is the voltage at this point? So, that we call as a instantaneous voltage. So, that's why here instead of small letter v, so instead of b, we put a small letter v. Because in the y-axis, it refers the instantaneous voltage. So, we need to find the voltage at this point. So, how to write this point? This is the instantaneous voltage V. V, we write in terms of Vm sin theta. For example, what is the instantaneous voltage at this point? Instantaneous voltage Vm sin theta. At this point, theta is equal to 90 degree. So, sin 90 becomes 1 into Vm. So, that's why we have a Vm. What is the voltage at this point? So, instantaneous voltage Vm sin theta. So, theta is equal to 0, sin 0, 0, 0 into Vm, 0. So, we get the 0 voltage. So, similarly, we can be able to find the voltage at this. To find this voltage, we must know the angle. If we know this angle, we substitute here, we can find the instantaneous voltage at this point. So, from this, what we understand, instantaneous voltage, we may write Vm sin theta. So, instantaneous voltage always refer in terms of maximum quantity and theta angle. But angle theta, it is a mechanical quantity. But we are electric engineers. That's why we write instead of theta, we write in terms of time taken. So that's why the formula rewrite as so instead of theta, we write Vm omega t. So we must remember this formula. In exam point of view, we are using this formula. Where omega is equal to 2 pi f. So that's why what is the voltage at this point? Vm sin omega t. Instead of theta, right now we are using the word omega t. So this formula is applicable for not only voltage, is applicable for the current, power. But right now we start with the voltage. So even though I keep here current, but it's applicable for voltage, current, power, always as we discussed in the previous class, the current depends upon the voltage. So always we start with the voltage, then we come to the current. After that we come to the power. So that's why always we reach the word voltage. Okay, then we come to that next third term. Instantaneous small letter V, second letter Vm, and the third letter RMS voltage. VRMS, which is equal to V. Either we use the word VRMS or V. So here we measure the voltage. The voltmeter is 240 voltage. This 240, whether instantaneous voltage, because we in the other hand, we have a stopwatch. The stopwatch time is changing, but the voltmeter always read 240 voltage. That's why it's not an instantaneous voltage, because instantaneous voltage time to time is changes, but the voltmeter reads 240 voltage. So the voltmeter reads is not an instantaneous voltage, it's not a maximum voltage, it is a RMS voltage. Unless otherwise specified, always what we read the voltage, all are RMS quantity. All the measuring instrument reads RMS voltage. So here we measure the voltage is RMS voltage. So we write VRMS or V. But this voltage we may write in terms of maximum quantity. How to write the formula? So now again you go to the mathematics. In the mathematics, we have a curve is there. In the integration, in the curve, we find the area of the curve. We can be able to find the area of the regular shape means we have a formula. For example, we have a square. We have what the area? We may say A square. And we have a rectangle. What the area? L into B. So we have a regular shape. We have formula is that. For the irregular shape, but it's a closed, we may use the integrations. So that's why here it is a curve. So it is in the curve. So that's why we need to find the area for this curve. We go for the integration. To find the area of the curve, first we must know the equation of this curve. What is the equation of this curve? Which is equal to V, which is equal to Vm sin omega t. This is the equation of this curve. Note that what I spelled right now, it is not asked in that exam. Just keep in the mind, if you are having able to get in, take that. Else, you forget about those things. So, but we need to by God the formula. How we derive the formula, it is not asked in that exam. So, we need to find the RMS voltage. RMS which stands for root mean square value. That we call as a RMS value. How to find this RMS value? VRMS, which is equal to, so f of x. In the mathematics, we say f of x. But in the electrical engineering, here what is the function? This is the function. So Vm sin omega t the whole square. F of x the whole square, but here the equation is Vm sin omega t. 0 to t. Here what is the period? 0 to 2 pi is a period, but in the complete cycle, the area becomes cancelled. That's why we are using the word 0 to pi divided by period pi. So we have a square and we need to root. So if we integrate this equation, we will get the answer. But in our exam, they didn't ask the derivations. How we get this value? They never ask that exam. So just for information only, but we need to by God this value. Simply So VRMS, which is equal to this equation, which gives 0.707 Vm, or if we integrate this, we get this value. So we need to bypass this value. It is not required, but it is too important. In our exam, they did not ask this equation, but this our exam, we need to use these values. So RMS voltage means Vm divided by root 2. We must bypass those things. What is the value of the root 2? In the calculator, we are using value 1.414. So Vm divided by 1.414, which gives 0.707 Vm. So that's why we are bypassed this formula. Okay. Vm by root 2, you could use the calculator 1 by root 2, which gives 0.707. So in exam point of view, just we bypass. Okay. Just we bypass this formula only. Okay, now we know what is the RMS voltage, how to calculate the RMS voltage. But what is the meaning for the RMS voltage? For example, we take a lamp. For example, say it's a 100 watts lamp. 100 watts lamp, we are giving 100 volt. Here is a DC supply. That's why we use the word 100 voltage DC supply. So the lamp is connected with the 100 volt DC supply. What will happen? The circuit is closed. That's why the lamp will produce some bright light energy. So right now we are getting this light energy. Assume that. But in the next classroom, the same lamp is there. But in this classroom, we have a DC supply. That's why we are giving the DC supply. We are getting this brightness. But next classroom, we didn't have a DC supply. We have a AC supply. So here we are giving the AC supply. But the next classroom also, we need the same brightness. Correct? To get the same brightness, how much AC voltage we need to give? How much AC voltage we need to give? To get the same brightness. That is the relations between the RMS quantity. That is understanding. So here 100 voltage DC supply, here AC supply. AC supply, we may see whether how much instantaneous voltage we need to give, or we may say how much maximum voltage we need to give, or we may say how much RMS voltage we need to give, or we may say average. We have 4 different terms are there. Which term we need to refer? So here we say to get the same brightness, we must give 100 voltage AC, VRMS. We need to give 100 voltage. That voltage refers to the RMS quantity, not the peak value, not the instantaneous value. So from this, what we understand, VDC, which is equal to VRMS. Here it is a VDC, it is a VRMS. So VDC, which is equal to VRMS. DC voltage, which is equal to RMS quantity AC voltage. Okay. So these are the things. Okay. But in our exam, how they ask the question? A lamp is connected with a AC supply. The 100 watts lamp is connected with the AC supply. What is the volt? How much voltage they give? 100 root T root 2 sine 314 T. That is this is the number. From this number, what do you understand? It is a RMS voltage, it's a RMS average voltage or instantaneous voltage or maximum voltage. The number refers. What is the formula for instantaneous voltage? Small letter v, which is equal to Vm sine omega t. There is a sine term is there. So before the sine theta, there is a Vm. Vm is a constant. So here we have one constant is there. So sine, they say sine omega t. Here t is there. That is omega. So the given data, it is a instantaneous voltage. They didn't mention. They didn't say instantaneous voltage. Simply they say 100 root T root 2 sine 314 T. This is the voltage they apply. Again, I repeat that the lamp is connected with the lamp is connected with the AC source. Voltage 100 root 2 sine 314 T. The same lamp is connected with the DC supply. To get the brightness, how much DC voltage we need to give? That means here we have a DC, the same lamp, we need to give the DC voltage. So we need to calculate VDC. How to find the VDC? So we know VDC, which is equal to VRMS. We know the VRMS. What is the formula of VRMS? VRMS, which is equal to Vm by root 2. Correct? What is the value of Vm? We get from the given data. So this is Vm sine omega t. So 100 root 2, which is a Vm. So we put here 100 root 2 divided by root 2. Root 2 cancel, we get 100. So that means we need to use 100 volt DC supply to get the same brightness. In our exam, we have a question like this. Or some other time, we may give the given data in terms of DC, we may find in terms of AC. The only thing, we must remember this formula. Sometimes they are given data in like this. Whatever the number, the 141 is a maximum voltage. So we need to find the VDC. So VDC, which is equal to VRMS, which is equal to Vm by root 2, which is equal to 141.4 by root 2. We use the calculator, we get the value. The same 100, we will get that. So again, note that you need to byheart the numbers. Get to use the calculator. In the calculator, we get the same number because 100 root 2, 100 into root 2, 1.414. The same number I put here. Okay. So in our exam point of view, RMS quantity, we must remember VRMS, which is equal to Vm by root 2, which is equal to 0.707 Vm, VDC voltage, which is equal to VRMS. That we remember, that's all. And these are the formula, just for your references. There is no need to byheart these formulas. And this slide also, just you byheart these two things. Okay, but the square waveform, triangular waveform is not required. In our exam, they didn't ask this square waveform, triangular waveform. Just we need to remember DC and AC, that is VM or VRMS is equal VM by root 2. That information alone you remember. Then you need to by heart the square waveform, triangular waveform. Because after getting your license, you may have some curiosity to read more things. That's why we keep these things. But in our exam, they never ask those things. Square waveform, triangular waveform. That's why that you need to by heart these values. It's not required for the exam point of view. And the fourth one, the last one, average voltage. Similarly, again, here also we are using that integration. Here we have an integration. In our exam, they didn't ask about the integrations, but we must remember this formula. V average, which is equal to 2 by pi Vm, which is equal to 0.636 Vm. So we must by heart this formula or these values. And we have two factors are there. One is a peak factor, another is a form factor. So peak factor means peak factor ratio between maximum quantity and RMS quantity is maybe a voltage or current. But right now we discussed about the voltage. That's why the peak factor, which is equal to maximum, that is Vm divided by Vrms. By this way we write that. That's all. Vm divided by Vrms. Okay. So we may write Vm, Vrms, we may write in terms of Vm. What is the value? 0.707 Vm. So from this, what we get? Vm cancel, we are getting 0.707, which is equal to root 2. So the peak factor is a constant, the value is root 2. And note that this is the constant exclusively for sinusoidal waveform. For the triangular waveform, is a different, but in our exam, they never ask those questions. So that's why we forget about those things. Peak factor value means root 2 or 1.414. So similarly, form factor. Form factor ratio between RMS quantity, average quantity. So form factor which is equal to VRMS divided by V average. What is the value of VRMS? 0.707 Vm. What is the value of average quantity? 0.636 Vm. So Vm cancel and divide this number, we get 1.11. So this is the form factor. So these two, the form factor we use in the EMF equation for the alternator transformers. Peak factor in the never we are using in any problems. But we just remember these factors because in our exam, they ask the definitions or they ask the values. So these are some questions related to these formulas. Find the average value for the sinusoidal voltage, small letter V, which is equal to 169.8 sin 377 T. So in this question, we need to calculate average. That is V average, they asked that. What is the formula? V average, which is equal to 0. V average, which is equal to 0.636 Vm. So which is equal to 0.36 into Vm. So this is the general formula V which is equal to Vm sin omega t. So from this we may get the value Vm. Vm is equal to 169.8. So we substitute 169.8 and multiply this number, we get the answer. That's all. Okay. Here the same question, they ask about the RMS quantity. So RMS quantity VRMS which is equal to 0.707 Vm, which is equal to 0.707 into 169.8. You multiply and we get the answer. That's all.
What is the formula in three-phase system? V average, VRMS.
Three-phase system, the same formulas that we discussed in the three-phase systems in the later stage. Find the frequency of for the given sinusoidal voltage. So they ask about the frequency. So frequency means, come to our mind, two frequency are there. One is a natural frequency, another one is a angular frequency. Natural frequency denoted by the letter F, unit is hertz or cycle per seconds. Angular frequency omega, radian per seconds. The given date, the options are in terms of hertz. That means we need to understood they ask about the natural frequency. So natural frequency, that is F. So we need to calculate the F. How to find the F? The given data, instantaneous voltage Vm sin omega t. So in this equation, omega t is equal to 377 t. Correct? Equal in this equation omega. So omega is equal to 377. So 2 pi f is equal to 377. So f is equal to 377 divided by 2 pi. So that is the frequency. Okay. So 377 divided by 2 pi, which gives 60 hertz. Suppose they ask the question like this. So find the angular frequency for the given data. So they ask about the angular frequency. Angular frequency means radian per seconds. Radian per seconds, we need to select the answer C. Because usually throughout the electrical engineering, we also see the word F. So due to curiosity, we calculate the frequency F, we get a 60 and we select the answer, this one. So read the questions carefully whether they ask in terms of cycle per seconds or radian per seconds. Based on the things, use the appropriate formula. So these are the formulas, summary of all these formulas. VPP means peak to peak voltage. So that's why we need to add the two numbers like that. So now we have AC voltage is there. So we have a voltage. Then what we do? We need to apply the voltage to the passive component. So what are the passive components are there? Resistance, inductance, capacitance. So right now we discuss about the passive components. So resistance denoted by this symbol. Inductance, capacitance. Resistance denoted by the letter R, unit is ohms. Inductance L in Henry, capacitance C in farad. But the three units, the three passive components having different units. For simple understanding, to solve the problem, all the units must be same. So that's why we convert the inductance. That is, we convert Henry into ohms. So thereby we can be able to use all the passive components having the same units. So that's why our objective, convert the Henry into ohms. The Henry means it's an inductance. So that's why the name is also changed. Instead of inductance, we call it as inductive reactance. The inductive reactance is denoted by the symbol XL. So inductance denoted by L, inductive reactance denoted by XL. What is the symbol for the inductive reactance? This is the symbol, the same one. So that means simply it is inductance. This is inductive reactance. Here the unit is Henry. Here the unit is ohms. So inductance, inductive reactance. So L becomes XL. So L becomes XL means there is some equation is there. So we need to convert. So what is the formula for the XL? XL is equal to omega L. So inductance is multiplied with the omega, then it is called as a inductive reactance. So XL is equal to omega L. What is omega? Formula for the omega is 2 pi f. So that's why we may write XL is equal to 2 pi f L. Okay? Clear? So we have an inductance 10 Henry. So we have two inductance, each same having a 10 Henry. So here we are applying a here we are giving the frequency 0 Hertz. Here we are giving the frequency 100 Hertz. What is the inductive reactance here? XL is equal to omega L, which is equal to 2 pi FL, which is equal to 2 into pi into 0 into 10, which is equal to 0. Here XL is equal to 2 into pi into 100 into 10, which is equal to 2 pi. Okay. So what is the unit here? Ohms. Okay. What is the meaning for the 0 ohm? In our construction activity, before starting the cable laying, we are using the mega test for the cable drum. So usually we do the mega test. So 0 ohm refers, as you told, that short circuit. Correct? 0 ohm means short circuit. Clear? So 0 ohm short circuit. So that is, here we have an inductance. L is equal to 100 10 Henry. Here we have an inductance. We are giving a 0 hertz. Then the XL becomes 0 ohms. Correct? As a inductance, there is a finite value is there. But in the inductance, if you are giving the frequency 0 hertz, the inductance becomes 0 hertz is nothing but a short circuit. So, if you are giving a 0 frequency, in the inductance behave as a short circuit. Then what is the meaning for the 0 hertz? What is the frequency for here? 50 hertz. What is the frequency for this battery? Here we are using the battery. What is the frequency for this battery? 0 hertz. Because the DC supply 0 hertz. So 0 frequency is nothing but a DC supply. From this, what we understand, in the inductance, if you are giving the DC supply, the inductance behaves as a short circuit. That information we keep in the mind. If you are giving a DC supply to the inductance behaves as a short circuit. Okay? Okay. Here we are giving the frequency 0 hertz, 0 ohms. 100 hertz, we have what the ohm? 2000 pi. So approximately we have a 6000 ohms are there. So frequency increases, but the XL value is increasing. So how we understand? XL is equal to 2 pi FL. So L is the inductance, is a independent of the frequency. So that's why we draw the graph. The frequency increases. Right now, inductance 10 Henry, 0 hertz, 0 ohm. 100 hertz, 2000 pi ohm. So frequency increases, the XL is increasing. So that's why the graph is just like this. So frequency increases, the inductive reactance is linearly, it is increasing. Note the word linearly is increasing because it's just like a straight line formula. Because the XL we write as a Y, the 2 pi and L we take as a constant. So because F is a constant, so the MX. X stands for frequency, 2 pi L becomes a constant. That's why it's just like Y is equal to MX. So we have a straight line. But as an electrical engineer, what we understand, if the frequency increases, the XL is linearly is increasing. If the frequency is 0, it will behave as a short circuit. Okay, now we come to the farad, we convert into ohms. So that's why the inductance we call as the capacitance, we call as a capacitive reactance, denoted by the symbol Xc. What is the formula? Xc is equal to 1 by omega c. So reciprocal. Earlier, XL is equal to omega L, here 1 by omega c. And which is equal to 1 divided by 2 pi Fc. So again, the same concept we apply. So 0 hertz. What the meaning? Xc is equal to 1 by 2 pi Fc. Put F is equal to 0, infinity. Whatever the capacitance value, infinity. So the Xc becomes infinity ohm. What the meaning for the infinity? Open circuit. So from this, what we understand, in a capacitor, if we are giving a DC supply, the capacitor behaves as a open circuit. So what is the voltage for the open circuit? The open circuit, there is a voltage is there. There is no current. When the current will flow, the circuit is closed, current will flow. Unless otherwise, there is a voltage. That's why the capacitor is act as a voltage storing devices. Okay, that will let me discuss in the later part. So right now, the frequency is 0, the capacitance behaves as a short circuit. And similarly, we may write Xc is equal to 1 by 2 pi Fc. So we draw the graph. Because it's just like a 1 by X format. So the frequency increases, the capacitor reactance, it is decreasing 1 by X format. So right now we have a 3 passive component, resistance, inductance, capacitance. Now in terms of inductance, capacitance, we use the word resistance, inductive reactance, capacitor reactance. The combination of all the device passive component, either series connection or parallel combinations, or simply we take it's a load. In this load, we are giving a DC supply, then this load is act as a pure resistance. If we are giving a AC supply, in that load we call as a impedance. If you are giving the DC supply, is resistance. If you are giving AC supply, we call as a impedance. Impedance is a combination of all these 3 passive components. So, if I put like this, means here it is called as a Z. Z is a combination of resistance, inductance, capacitance. So, how to understand easily? We know the word choke or ballast. The choke ballast, what is the meaning? Just we have a copper binding. In the tube light, nowadays we are using the electronic ball. In the earlier days, we are using the tube light. In the tube light, we have a choke is there, or we call it a ballast. The ballast is nothing but is made up of copper coil. So the copper, here we have a coil, the coil having resistance, inductance. So here we are giving a DC supply. So here we have a R, L is there, we are giving the DC supply. Here all L is there, we are giving the AC supply. So frequency, what is the frequency? 0. Because the DC supply. Here it's a R, it is a L. Here frequency, that's why the L becomes XL. XL is equal to 2 pi FL. F is equal to 0, that's why XL is equal to 0. So physically, resistance, inductance present there, but behave as a pure resistance because it's become a short circuit. So even though resistance and reactance are there, the resistance, inductance are there, but the entire circuit is behave as a resistance only. That's why we told that any electrical load, if you are giving the DC supply, is just like a resistance. But if you are giving AC supply, it is become a RL. So commonly we use the word, we call as a Z, impedance. So that's why resistance, we are giving a DC supply. If you are giving AC supply, we call as a impedance. The impedance is a combination of resistance, inductance, capacitance. So that's why we use the word Z. Z is a function of R, XL, XC. We have a resistance and we are giving a AC supply. How much voltage we are giving? We are giving the instantaneous voltage, small letter v, Vm sin omega t. This voltage we are giving. So what will happen? There is a passive component, there is a source. So the circuit is closed. So that's why current is flowing. So we are giving instantaneous current, voltage. That's why it's a instantaneous current. Okay. We are giving the voltage, there is a current is flowing. How much voltage we are giving? Vm sin omega t. That is, this is the voltage. This is the voltage we are giving. How much current flowing? I current. How to find the I current? By using the Ohm's law, I is equal to V by R. Okay. What is the V? V is equal to Vm sin omega t by R. Okay. What is the Vm? Vm is a constant. Because Vm is a constant. It may be a 10 voltage, it may be 15, whatever number. R is a constant. In respect of any frequency, is always constant. But that omega t is changing in nature. That's why I rewrite the formula Vm by R into sin omega t. So from this, I write small letter I, which is equal to small letter I, which is equal to Im sin omega t. So we are giving this voltage, we are getting this current. Okay. So this is the waveform what we give. This is the current what we get. But we have to draw the graph waveform for the current. How to draw the waveform? So both the voltage and current, the common term is a omega t. Omega t at 0, voltage is 0. What about the same omega t? Put omega t 0. So sin 0 becomes 0. So 0 into Vm 0. So that's why voltage is 0. At the same time, what is here? Omega t sin 0, 0, 0 into Im 0. So the current is also 0. At 90 degree, voltage maximum, current maximum. That's why the waveform is just like this. So at 90 degree, both voltage and current are maximum. Okay. So from this, what we understand? Voltage and current are flow in the same direction. Correct? Voltage at 0 degree, voltage 0, current 0. At 90 degree, voltage maximum, current maximum. So that's why this is the waveform. This waveform we may draw as a phasor diagram like this. This is the voltage. This is the current, because both are flowing in the same direction. So what is the angle between voltage and current? 0. So that the phase angle, so angle between voltage and current is 0. This angle in the electrical engineering we call as a phase angle. The phase angle is denoted by the symbol pi. So that's why pi is equal to 0. For the resistance, the phase angle is 0. Then another important thing, power factor. What is the definition for the power factor? Power factor is cosine angle between voltage and current. So cosine angle between voltage and current is nothing but a cos pi. So cos pi is equal to cos 0. Cos 0 is equal to 1. So that's why for the pure resistance, the power factor is 1. So from this, what are the information we'll remember? Power factor, cosine angle between voltage and current. Number 1. Number 2, for the pure resistance, the angle between voltage and current is 0 degree. Okay. So this is for the pure resistance. So we may draw so now we have a inductance. We call it a pure inductance. So we say L. So we are giving Vm sin omega t. So what will happen? The circuit is closed. That's why the current is flowing. Okay. So the current which is equal to B like that. So we forget about these values. So instead of like that, because now we understand about the concepts. Here we are giving the voltage, it is in this direction. What about the current? Now, how we understand easily, the resistance is just like here. As a father, I bring my son, my son is a school going son. Now, myself, I bring my son, we are going to the park. So this is the entrance. I am standing in the entrance. My son is a school going son, he's a small chota boy. So that's why he hold my hand. And he is standing along with me. I step one step forward, he is also put one step forward. Maybe my step is only 1 feet, we may say it's a half feet. We forget about the amplitude, the direction. Both are flowing in the same direction. That's why we use the word in phase. So pure resistance is just like a school going student. Now, after a few years, he become a college student. Both of myself, my son going to the park, but he never hold my hand because he is a college going student. I am standing in the entrance, but my son, he didn't hold my hand. He always behind me because he's a adult. So he have more activity. We may have that. So that's why he behind me. So note that he's behind me. So I am standing in the 0. Because voltage is a references. So I am standing in the gate, 0 degree. My son standing in behind me. How much is behind me? It's a 90 degree behind me. So that's why the current is behind the voltage, behind the father. So here current, for understanding purpose, I put IL. How much angle is a 90 degree? So what is the phase angle between voltage and current? 90 degree. What is the power factor for the pure inductance? Cos pi, cos 90, 0. That's why the pure inductance, the power factor is 0. But phase angle is 90 degree. And more specifically, behind, that's why we use the word lag. Because as a father, what I told that my son behind me, he always lagging. We told like that. Now we take a capacitance. So pure capacitance. After college, what will happen? She got married. She got married. Definitely, she didn't follow the father. So I am standing in the entrance, but he leads, hold his wife's hand and leads me. So I am standing here, but he is standing one step ahead of me. So that's why he's leading me. So that's why here we put current. I see. For understanding purpose, I put a, so we have a 90 degree. What is the 90 degree? The 90 degree stands for leading. So come to the point, resistance phi is equal to 0, resistance, voltage, current, phase angle 0, power factor 1, inductance, voltage, we have a current. Okay, current phi is equal to 90 degree lag. Power factor, we have a lagging. Depends upon the angle. Sorry. Power factor is equal to 0. Okay. Capacitance, zero. Okay. Note that pure resistance, pure inductance, pure capacitance. But in the real time, so there is no need to use for the pure resistance, we may use, but pure resistance, inductance, capacitance not possible. So we may use the combination of those things. So that's why now we come to the three categories. So if there is a pure resistance or RL circuit or RC circuit or LC circuit. So right now we draw like that. Or RL, RC, or LC. Okay. Here, the phase sign, we are giving the voltage. So current, it's in phase, is RL circuit. What is the RL circuit? R means pure in phase. L means lagging. But it's a RL circuit. So actually, the lines between here. This is for the resistance. This is for the inductance. So we have two components are there for resistance in phase for understanding purpose. For understanding by inductance, we have a 90 degree lag. But the current is the combination of these two components. That's why it's like this. So the angle is like this. Here theta is equal to 0. Here theta is equal to lies between 0 to 90 degree. Lies between 0 to 90 degree, but it's not exactly 0. It is not exactly 90. Because exactly 0 means it's a pure resistance. Exactly 90 means it's a pure inductance. So the value lies between 0 to 90 degree. But anyhow, it is a lagging. So here, the same blue color here. Okay. So that's why here also the theta is equal to 0 to 90, but only thing here is a lead. Here, so it's a RLC circuit. So voltage okay, current okay, but inductance capacitance, they have two components are there. Depends upon the inductance and capacitor value. If the capacitance is high, then it becomes is behave as a RC circuit. If C high, behave as RC circuit. If L high, behave as RL circuit. That's all. But physically, all the components are present. Okay. So these are the different combinations. But in exam point of view, right now, we need to discuss about the formulas. So have a small break. So after the break, we discuss about the formulas. Sorry. So have a 10 minutes break. After the break, we discuss rest of the things. Okay, shall we start? So now we discuss about the RLC circuit. And now we discuss some formulas. These formulas are important for our exam point of view. Just remember those formulas. So RLC, and we are giving the voltage. So the circuit is closed. What will happen? The current is flowing. The current flowing to the resistance, the current flowing to the inductance, current flowing into capacitance. Current flowing to resistance, which gives the heat energy. If the current flowing to the inductance and capacitance does not produce any heat energy, which means these two components which is used to store the energy. All this passive component, this passive component produce the heat energy. This passive component does not produce heat energy. So the heat produce the heat energy is wasted. But here it's not wasted, it is stored. So that's why these three components divided into two parts. So here we have a heat dissipated. So here, so simple understanding. Here storage. Here no storage. So it is dissipated. Okay. So the heat dissipated, that's why it is called as a real component. Here it's a storage device, that's why it is called as a imaginary component. And these two, inductance, capacitance, both is an energy storing device. But inductance, energy stored in the form of current. Capacitance, energy stored in the form of voltage. Or in other words, inductance, it is a lagging power factor, it is a leading power factor. So we have two different things are there. So how to distinguish these two things? That's why we put a resistance. Here we have an inductance. We are giving the AC supply, that's why instead of X, L and C, I put a XL and XC. This through is a energy storing devices, energy stored in the form of current, energy stored in the form of voltage. Okay, both are an imaginary component. So how to represent the imaginary component? In the mathematics, we use the I. Z is equal to X plus IY. This is what we studied in the complex number. So X is a real component, Y is an imaginary component. So similarly here, this 2 is an imaginary component. That's why I put here J symbol. Instead of I put here J. Because these 2 is, why didn't we put a J? Because it's not an imaginary component. These 2 imaginary component, it is stored in the form of current, it is in the form of voltage. So that's why we have different things are there. So here we put a plus symbol, here we put a minus symbol. Or we may say it is a lagging power factor, we put a plus, leading power factor, we put a minus. There is another definitions, exact definitions is there, but easy to understand, like this way easy to understand. Here plus, here minus. So it's a, now we come to the mathematics. Z is equal to X plus IY. X is a real component, Y is an imaginary component. It is, we call as a rectangular format. We convert the rectangular form into polar form. How to write the polar form? So this is, we call as a polar form. Rectangular form, Z is equal to X plus IY. Polar form, model of Z, angle theta. How to find this model of Z? Which is equal to root of X square. X square plus Y square. This is what we studied in the complex number. That is, Z is equal to square root of real component plus imaginary component. So now we apply the same mathematics in the engineering. So Z is equal to real component plus imaginary component. Imaginary component simply we use the word X. Or we may rewrite this formula like this. These two components put together, I put X. But here, for my convenient, let J I take the common, so plus J XL minus XC. So now we may write Z is equal to R plus J XL minus XC. Or we may say R is equal to, sorry, Z is equal to R plus JX. So both are same. Here X plus IY, here R plus JX. How to find the here? The same formula using. Okay. Okay. So this is the formula to calculate the impedance. Z is equal to root of R square plus XL minus XC the whole square. So again I rewrite for RL circuit, Z is equal to root of R square plus okay. And what is the Z? Z is equal to root of R square plus XL square. Z is equal to R square plus XC the whole square. Z is equal to R square plus XL minus XC the whole square root. Or we may write R square plus X square where X is equal to XL minus XC. That's all. Okay. But by God, this formula is applicable for both those things. For RL circuit, RC circuit. That's why always we discuss RLC circuit. Here. Usually, so this is the formula. So minus 6 the whole square becomes plus. That's why we write straightly we write that. Okay. So here we have a impedance triangle and power triangle. So resistance, reactance, impedance. Why we write that? Because it is the, even though we may write Z is equal to X plus IY, or in the mathematics what we told that here we have a voltage, here we have a current IL, here we have a IR, correct? For RL circuit. So what is the angle between IR and IL? 90 degree. So the same 90 degree we put a R and X. So the angle between resistance and inductance is 90 degree. That's why we write this. So here resistance, reactance, impedance. The reactance is the combination of XL and XC. So it is we call as a impedance triangle. Z is equal to R plus JX, or you may say R square plus X square. So here we have R. In the passive component, we are giving the voltage, thereby current is flowing. If the voltage and current is flowing, then we have a power. So the power consumed by the resistance denoted by the letter P. Power consumed by the reactance denoted by the letter Q. Power consumed by the impedance denoted by S. The P we call as a real power, or we may say active power, or we may say true power. So power consumed by the resistance, we call as a heat energy. So that is a real power. So that's why real power, active power, true power, all represented by the letter P. So always in the electrical engineering, the power means denoted by the letter P. And Q we call as a reactive power. So reactive power is referred power not consumed, power stored in the reactants, either inductive reactants or capacitance. Simply we say reactive power. Power consumed by the impedance we call as a apparent power. Okay. What is the formula for the real power? P is equal to V into VI cos pi. Reactive power Q is equal to VI sin pi. Apparent power S is equal to V into I. So here Z is equal to R plus JX. So here we may write S is equal to P plus JQ. Correct? Z is equal to root of R square plus X square. So here also we may write P square plus Q square root. So VI square, VI, V square, I square, cos square, V square, I square, cos square, plus V square, I square, sin square, root. So V square, I square common, cos square theta plus sin square theta becomes 1. That's why we say S is equal to VI. Directly we write that. So because in our exam, that you don't need to remember the trigonometrical formulas. That's why simply we say S is equal to V into I. That's all. Okay. Okay, this is the formula for single phase system. For three phase system, P is equal to root 3 VI cos pi. Q is equal to root 3 VI sin pi. S is equal to root 3 V into I. That's all. Okay. So, impedance triangle, power triangle. From these two triangle, we must remember all the formulas. So, power factor, cosine angle between voltage and current. So, power is equal to V into I, cos theta. So, this question frequently asked in the exam. What is the definition for the power factor? Cosine angle between voltage and current. So, just we need to solve this problem. That way we understand all the formula what we discuss. So, here we need to find the voltage across 50 ohm resistor. That is, we need to calculate okay. How to find the VR? We go to the Ohm's law. VR is equal to I V is equal to I into R. Correct? So that's why we put so I into R. So to avoid the confusions, we take V1. Okay. So V1, which is equal to current flowing to the resistance into resistance. By this way, you understand easily. Because you put IR into IR means we may confuse the letters. So they must find this one. So what is the R? 50. What is the I1? They didn't give that. So what is the I1? I1 is current flowing into the resistance. But this is the series circuit. The series circuit, what is the current? Same. So that's why what is the I1? I1 is nothing but a total current. That means I1 is equal to IT, total current. How to find the total current? Again, go to the Ohm's law. So total current, which is equal to total voltage divided by total resistance. But in the DC fundamental, we say total resistance. But it is a AC fundamental. So instead of total resistance, we use the word impedance. So that's why here is that. What is the total voltage? 50 voltage. How to find the impedance? Is that? No, they didn't give that. So we need to find the impedance. How to find the impedance? Z is equal to R plus JXL minus JXC. Or we may say Z is equal to R square plus XL minus XC the whole square root. So we prefer the second one because we need to magnitude. What is the, how to, first we need to find the Z. To find the Z, first we need to find the R. Yes, R is equal to 50. XL, whether they give that? No. They give only L. So we need to find the XL. XL is equal to 2 pi FL. L is equal to 0.2 Henry. F is equal to 160. They give that. So we may use 2 into pi into 160 into 0.2. We get XL. Similarly, XC is equal to 1 by 2 pi FC. 1, 2 into pi into 160 into 4 into 10 power minus 6. So we find the XC, we find the XL, we put this value here, we can able to find the Z. Then this value we put here, we find the current. Then we put the here, we get the total current. We substitute here, we get the voltage. First find the XL, 2 pi FL, we substitute the value, we get 200 ohms. Then XC, then Z, then total current into resistance, voltage. But note that this question not asked in that exam because it takes more time. But to understand all the formulas, just solving one problem. Just to solve this only one problem, all the formulas what we discussed, we may use here. Okay. And we know how, what the sequence, how to follow the steps. So that's why try to solve this problem at least one time in your home. That way you can able to remember all the formulas. Suppose the same given data, they ask the power factor for the given circuit. But note that the power factor they didn't ask about the exact number. They ask about the either unity, lag, or lead. So how to find the unity means the circuit having resistance, inductance, capacitance, but if it is behave as a resistance, we call the unity power factor. When is a lagging power factor? If it is behave as a RL circuit, we have a lagging power factor. If it is behave as a RC circuit, unity power factor. But all the components are present. So here is a 50 ohm, here 200 ohm, 248 ohm, correct? But 248 is a capacitor reactance. So capacitor reactance is denoted by minus J. 200 inductive reactance denoted by plus J. Then what is the Z? Z is equal to 50 plus J 200 minus J 248. Correct? J 200 minus J 248, we may rewrite 50 minus J 48. Correct? So 50 minus J 48 means R minus J. That is RC circuit. Actually, the circuit having all the component. Circuit having all the component, but behaves RC circuit. So myself, if I am working in my office, I behave as a pre-sales engineer. The same person, I am working in my home, I am as a husband. Here, so the same, all the components are present here, but behave as a RC circuit. RC circuit means what is the power factor? Leading. That's why answer is C. Okay.
So we can also assess by the value XL or XC.
Yes.
Because the greater XC means capacitive.
What is the value? 0.24 microfarad. Yes. Yes, different. 200, 240, which is the biggest number? 240 is the biggest number. That's why we say C. But easy to that is the right answer. But it is all from this circuit. What we say? It's a RLC circuit. So from this, what we say? It is a RLC circuit, but behave as RC circuit. So that's why we say leading. That's all. Okay. Then we come to that next topic, that is resonance circuits. So resonance circuit means the same RLC circuit. The same RLC circuit. Here we have voltage, frequency. Sometimes we may use voltage constant, we change the frequency. Sometimes frequency is constant, change the voltage. Where we are using, so in Qatar we didn't use the ceiling fan, but usually in my home country we are using the ceiling fan. How to control the ceiling fan? We are using the voltage regulator. The ceiling fan always operated with 50 hertz. Either it is in the high speed or low speed speed, but the ceiling fan operates with the same frequency. So the frequency remains same. By adjusting the regulator, we increase or decrease in the voltage. So that's why the frequency is constant, the voltage is changed, then it is called as a electrical circuit. Okay. Now we take in a college days, right now we are using that mobile phone as a FM radio. But in the earlier days, we have a big box is there. There is a two knob is there. One knob volume control, another knob we call it various station. This radio we are using two cell. to battery. That is, voltage is constant, either AC or DC. But by adjusting the knob, we have a different stations. That is, we change the frequency. So in this circuit, we keep the voltage frequency constant, we change the voltage. In the RC circuit, in the resonance circuit, the voltage is constant, we change the frequency. If we change the frequency, what will happen? The behavior is changing. L and C depends upon the frequency. That's why the behavior entirely changes. That is related to the resonance circuit, which is used in the communication. So simply in the radio or in the communication circuit, either receiver or transmitter. In the both the cases, this resonance circuit is play the vital role. So we keep the voltage constant, we change the frequency. For simple understanding, in our college days, in our electronics laboratory, we are using that AFO, audio frequency oscillator. From this audio frequency oscillator, we rotate the knob, thereby we are giving the various frequencies. At the same time, we come to the electrical lab, we are using the RPS. In the RPS, we rotate the knob, that way we change the various voltage, DC voltage. We come to the electrical lab, we are using the auto transformer or variac, three-phase variac, single-phase variac. By adjusting the variac, we change the voltage, but frequency remains constant. So here we are using that AFO. So we change the frequency. That is, we saw example say, we are giving the zero frequency. 10 hertz, 20 hertz, 100 hertz. By this say, we increase the frequency, we put here. So in the y-axis, we have three components are there: resistance, inductance, capacitance. We take the L. Because if you give the inductance, if you are giving the frequency, it is called as a XL. That's why you put a XL. What is the XL formula? XL is equal to 2 pi FL. So frequency increases, the XL is linearly increases. That's why the graph is just like this. Okay. We are applying the frequency. The same frequency is applicable for capacitance also. So that's why for example, say frequency F is equal to 0. What is the XL value? XL value is 0. What is the XC value? Put X is equal to 0, 1 by 0, infinity. So we have like this. So by this way, we increase the frequency, the XL is increasing, XC is decreasing. Okay. At the same time, we are giving the frequency. What about the resistance? Resistance is independent of the frequency. The frequency increase or decreasing, the resistance value never change. So from this graph, what we understand, if the frequency increases, the resistance remains constant. XL is linearly increasing. XC is linearly, that is 1 by X format, it is decreasing. Okay. So in the AFO, I rotate the knob 0 hertz. I give the 0 hertz, XL 0, XC infinity or constant. I again rotate the knob, that is I increase the frequency, it is increasing, it is decreasing. By this way, I increasing the frequency, one particular point, what will happen? One particular point means one particular frequency. So all the points are meet. So this point at this frequency, when I apply this frequency, R, XL, XC, all are same. Okay? So now we come to here. Z is equal to R plus J XL minus XC. So this is the Z, correct? This is the formula for the any frequency. At this frequency, what is the value of XL and XC? Both are same at this frequency, because see the point, both values are same. So at resonant frequency, XL is equal to XC is equal to R, because all the point meet one point. So XL is equal to XC. So we may write XL minus XC is equal to 0. For understanding, we forget about this. Correct? Now this. So this is the equation for the impedance for the any frequency. At this frequency, what is Z? Z is equal to R plus J becomes 0. XL minus IC becomes 0. So that's why Z is equal to R. So from this, what we understand, this is the RLC circuit. At this frequency, this RLC circuit behaves as resistance. Then what is the power factor? Unity power factor. So if a resonance or if a circuit operate at resonant frequency, then the circuit having a unity power factor. That information we will remember. So Z is equal to R. What is the power factor? Power factor is unity. Okay. Okay. At this frequency FR, how to find this frequency? So what is the formula? So XL is equal to XC at this frequency. What is the XL? 2 pi FL. What is the XC? 1 by 2 pi FC. Correct? XL is equal to 2 pi FL. XC is equal to 2 pi FC. But here instead of F, I put the FR. Because I put a equal to, that's why I put the resonant frequency, FR. Correct? So rewrite this formula, FR square, which is equal to 1 by 2 pi square into LC. The FR, we come to the left side, 2 pi L, we come to the denominator. So FR is equal to So this is the formula to find the resonant frequency. FR is equal to 1 divided by 2 pi root of LC. What is the unit? What is the unit for this resonant frequency? Hertz, because we are using the word FR. So what is the unit resonant frequency formula? FR is equal to 1 by 2 pi root LC. Can we find the resonant frequency in terms of radian per seconds? That is in terms of units of FR, I write 2 pi FR is equal to 1 by root LC. The FR, we come to the numerator. That is in the cross multiply. 2 pi F which is equal to omega. So 2 pi FR which is equal to omega R. So omega R is equal to 1 by root LC. So we must remember this formula and this formula. FR is equal to 1 by 2 pi root LC. This is natural frequency. And omega R is equal to 1 by root LC. It's a angular frequency. So in your exam, they may ask the resonant frequency in terms of hertz or radian per seconds. So remember both the formulas. So series resonance, XL is equal to XC. So Z is equal to R plus J XL minus XC. So Z is equal to R plus J 0. That's why you put Z is equal to 0. In other words, what is the meaning? XL minus XC is equal to 0. Correct? What is the unit? X is equal to reactance. Reactance unit is ohms. So 0 ohms. Correct? 0 ohms. What is the meaning for the 0 ohms? Short circuit. So see that word resistance, inductance, capacitance for any frequency. At resonant frequency, it becomes a short circuit. In RLC resonance circuit, at resonant frequency, L and C behave as short circuit. So that's why we see that. So now we short circuit, then it is simply, it's a R. That's why we say Z is equal to R. So this one. So Z is equal to R. That's why power factor is equal to 1. Current. What is the formula for the current? I is equal to V by Ez. What is the Z? V divided by root of R square plus X square. Correct? At resonant, this is the formula for any frequency. At resonant frequency, the X value becomes 0. So denominator is reduced means whatever the value, that is, for example, 1 by 5, 1 by 10, 1 by 1. 1 by 10 becomes 0.1. 1 by 1 becomes 1. So denominator is reduced. Denominator reduces, the value is increasing. That's why this X value, the impedance is reduced, thereby the current is increases. So that's why we say current is maximum. So Z is decrease, that's why current is increase. On one particular point, reactance becomes 0, that's why the current is maximum. We say that. How to find the current? I is equal to V by Z. But here there is no X, so only R. That's why V by R. So that's why the maximum current which is equal to V by Z, which is equal to V by R. So current is maximum. Already we told that power is constant. Power is constant, current is maximum. What about the power? Power is equal to current into voltage. So voltage constant, current is maximum. That's why power is also maximum. When did this happen? At resonant frequency, the power is maximum. So these are the informations we will remember. So we have direct questions. Without doing any mathematical problem, we ask these direct questions. So below the resonant frequency and above the resonant frequency. What we discuss? So this is XL, this is XC, correct? And this is the point, resonant frequency, correct? So this area we call as a below resonant frequency, correct? Correct? Below the resonant frequency, which is the highest, XC or XL is high? XC is high. If XC is high, what is the power factor? Leading power factor. That's why below the resonant frequency, XL is low, XC is high. That's why power factor is leading. So vice versa. Here, this area above resonant frequency. Above the resonant frequency, XL is high, XC is low. So X low, XL high. So that's why lagging power factor. So these also direct questions. That you want to just remember only this graph. Okay, resonant frequency. This is what we the circuit diagram. So here the frequency versus reactance, that is XL. So frequency versus XC. So put together we draw in the same. So from this we understand at resonant frequency XL and XC are same. So we derive the formulas. So it is XC, it is XL, it is R. Okay, that is XL, XC, R. All the components put together we call as a impedance. So the frequency increases, what will happen? The impedance Z is equal to R plus JXL minus JXC. Or we may say Z is equal to root of R square plus XL minus XC the whole square. So ZR is constant. XC is high. XL is low. So what about the impedance value? So impedance value always high. So the frequency increases, what will happen? It is decreasing, it is increasing. That's why the graph is just like this. The green color refers frequency versus EZ. So from this, what we understand, the frequency increases, EZ value is decreasing. Decreasing. At resonant frequency, Z is equal to R. Okay? And frequency increases, again impedance is increasing. Or simply what we understand, So frequency versus impedance is just like a U shape. So frequency versus Z is a U shape. So now we need to draw the frequency versus current. We need to draw the frequency versus current. What are the relations between Z and I? I is equal to V by Z. So V is a constant. So I is inversely proportional to 1 by Z. Inversely proportional, what the meaning? Is opposite. Z, it is in the, Z is high means current is low. By this way we understand. So Z is a U shape, but I is a inversely, that's why inverted U shape. So it is a U shape, it is in like this, that's all. Simple understanding. Frequency versus impedance, U, frequency versus current, inverted U, that's all. Okay, from this we can able to find the bandwidth. So we will discuss the rest of the topic bandwidth and rest of the topic in the next class. Coming Thursday, we have a next class. We will discuss about this bandwidth and quality factor, transient circuit, network theorems. Okay. Thank you. See you in the next class. Hello, sir. Thank you, sir.
Thank you, sir.
Thank you, sir. बहुत शुक्रिया, sir.
Thank you. Thank you.